Hello everyone, in this video we are going to be considering the Sarrus rule. This is a continuation of the series of problems we've been working on matrix determinants. To see one of them, just click on the link at the top right hand corner of your screen. Now the Sarrus rule helps us to compute the determinants of a 3 by 3 matrix. Let's consider this 3 by 3 matrix. To obtain the determinant of this matrix using the Sarrus rule, we are going to assume that this last column is a mirror line that reflects the other two columns. So if this is a mirror line, we are going to see that A11, A21, and A31 would be reflected on the other side. Similarly, A12, A22, A32 would also appear as an image on the other end. The next thing would be to put positive signs at the top and negative signs at the bottom. But how does this work? This is how it works. It's very easy. We are going to start with the first element here, A11, and run a diagonal line like this. So we would see that A11, A22, and A33 fall on the same diagonal. So we are going to have the product A11 times A22 times A33. We've got a positive here. Then we will do the same, run a diagonal. So we are going to see that this would catch A12 times A23 times A31. Then the final one, the diagonal, like this. So it's also a positive. So this is A13 times A21 times A32. So we can see our movements from left to right. So we are done with the first part. Then we are going to move on to the next one, the negative portion. So all of these are positive portions. So these are all positive. So we're going to move on to the negative. So since we've got negative, 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 I could just factor out the negative. So this is how we are going to move on the last one. So we're going to start from the very last item here, A12, introduce a diagonal. Then the second to the last, introduce another diagonal, like this. Then finally, the third diagonal. So we can see that. So here we have A13, A22, A31. Now, because we already factored out the common negative, so we can just have a positive here. Then the next one, A11, A23, A32. Then finally, A12, A21, A33. So this is the determinant of the 3 by 3 matrix. Let's have a quick example. So in the previous video, we obtained the determinant as 0. So we want to see if we're also going to arrive at 0 here. So the very first step would be to assume that the last column is a mirror line that reflects the first two columns. So we are going to have 0, 1, 3, 4, and 6, 7. Next, we would have positive, 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 negative, negative, negative. So the positive here is going to move from left to right. The first element here is 0. So if we introduce a diagonal, it's going to catch 0, 4, 8. So we are going to have 0 times 4 times 8. The next item is 1. This is going to catch 1, 5, 6. So we have 1 times 5 times 6. Plus, the next item is 2. So the diagonal is going to be 2, 3, 7. So this is 2 times 3 times 7. We are done with the positive parts. Then negative. So we're going to do the same. 1, 3, 8 here. Then 0, 5, 7. The next diagonal. Then 2, 4, 6. So since all of them are negative. I factored out the negative here, so I have 2 times 4 times 6 plus 0 times 5 times 7 plus 1 times 3 times 8. So 0 times 4 times 8 is just 0. 1 times 5 times 6 is a positive 30. 2 times 3 is 6. 6 times 7 is 42. So in brackets, minus 2 times 4 is 8. 8 times 6 is 48. Plus 0 times 5 times 7 is just 0. Plus 1 times 3 times 8 is 24. 30 plus 42 is 72. Minus 48 plus 24 is also 72. So the determinant of C is equal to 0. And this tallies exactly with what we got in the previous video. So this is Sarrus rule. I leave it to you to decide which one you prefer, the Sarrus rule or the previous method. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.